This video will describe the increasingly relevant topic of climate change, how it affects farmers now, and how that might change in the future, and outline proactive solutions for Rio Grande Valley farmers. Average global temperature increases are linked to industrialization and fossil fuel combustion. Gases from fuel-burning traps heat like a greenhouse. The International Panel on Climate Change expects temperatures to rise by 2 to 4 degrees Celsius by mid-century and 3 to 5 degrees Celsius by the end of the 21st century. Barry Goldsmith is the warning coordination meteorologist for the Rio Grande Valley.
So we're currently in a warming cycle, and warming tends to be related to the amount of carbon dioxide in the atmosphere, which going back 500,000 years has shown a cycle of up and down. We're in the upside now. There's also an anthropogenic warming component that has increased the amount of carbon well above what it should be in this current warming cycle. That increase is due to the Industrial Revolution and all the burning of fuels that now go up into the atmosphere as a carbon source. The long-range forecast is for hotter and drier, and that means more evaporation and less water available.
Global warming is associated with increased hurricane intensity.
The numbers aren't as much the issue as the intensity of the storms that are out there. Hurricane coming in, working off of warmer water is going to bring higher storm surges in as well. And don't forget about sea level rise. We're seeing the sea level rise that is a natural occurrence but being boosted by greenhouse gas warming as we're seeing enhanced melting around the poles. We're talking about slowing the rise. And that's going to take decades just if we shut it off tomorrow. We're not doing that.
The Rio Grande Valley is the southmost part of Texas and one of the largest agricultural production areas in the state. This area predominantly uses irrigation techniques to provide their crops water. Because of the subtropical climate and the geographic location of the valley, some issues of climate change will be unique to this area. Rainfall is one concern for the farmers of the valley.
Texas is a state of perpetual drought broken by the occasional devastating flood. The average rainfall in the lower valley is about 22 to 27 inches. In the upper valley to the Rio Grande Plains in Zapata County by the mountains there, it's only 17 inches. We have mountains on the west, and if the atmospheric pattern has a high pressure ridge deep in the atmosphere from those mountains eastward here to the lower valley, it suppresses all moisture. We get a lot of our water from reservoirs in Mexico and the US. That's where a lot of it comes from. If those reservoirs dry up, water's not going to be available for the state of Texas, in particular the Rio Grande Valley, which is growing rapidly. We're going to need to have enough water sources to provide for both agriculture and people that are living here, and our population is growing very rapidly.
Amistad and Falcon Dam are local water sources for farmers on both the American and Mexican side of the border. This water is limited and important for farmers on both sides. Troy Allen is the general manager of the Delta Lake Irrigation District.
And a majority of our water is stored behind Amistad. Right now, U.S. has a little over 80% of their water behind Amistad and only 20% behind Falcon, where Mexico has about 80% of the water behind Falcon. All the other cities in the valley rely on irrigation districts to divert their water. There's a lot of groundwater, but they're having to go 800-900 feet to find some of their water.
It was just too dry, and the recycle water is not good. When it's dry, when it is so little rain, the recycle water gets really salty.
Salinity is another major concern for local farmers, and it is measured by electrical conductivity. Part of the concern of using groundwater for growing crops is the EC level. Bud and Sue run Acacia Farms, a local organic farm.
Or the EC of the soil is higher than the EC of the plant. It can't use the water that's in the soil. Instead, the soil is taking moisture from the plant, and that's why they look wilted. The Rio Hondo water, the city water, is about 1.57, and we checked the EC of the recycle water, and it was 4.52, extremely high.
Over twice as much. But in order to reduce it to something that'll still allow you to grow, it takes tons, literally tons of sulfur.
And calcium.
With the increase in temperature and decreases in precipitation predicted, the availability and the quality of water become a challenge to people trying to water their crops. There are many solutions to help farmers conserve water quality. One way is to use minerals to draw out the salinity. When water evaporates from the soil, it leaves behind salts, pesticides, and fertilizers, further increasing the EC.
If the calcium is not available in the soil, then you have to add calcium. But they're both allowed in organic farming. It's a mineral, and you just buy the raw mineral.
Evaporation is the ruling principle here. Evaporation rates are going to go much higher than they already are now between, say, May, June, July, August, September, October. Even if you put retention ponds, they're going to evaporate too, so you need to find ways of conserving the water.
I think drip irrigation is the most efficient.
There are additional ways to conserve water, such as drip irrigation, a method where water flow rates are controlled by spray nozzles and directed with hoses and piping. You control the output of the water, so it is easier to monitor water use. Since the water is protected in tubes, it won't evaporate as in the case with flood irrigation.
You can give each plant, or at least each row of plants, a specific amount of water.
Other solutions include
Desalination is one option. You could build some desalination of salt water to help the cause, as well as brackish water that is under the ground in Texas. If you want to grow for a long time in a drought situation, we'll have to be looking at drought-tolerant crops. And they may not be the normal crops we're used to growing down here. Water harvesting. Water harvesting is when it rains, you can have cisterns or some kind of source of water retention that can catch and collect a lot of water when it rains hard and keep it for your use there. And finally, reclamation and reuse of water. So right now there's a lot of water going into the ground from, let's say, sprinkler systems and the sinks and whatnot that just goes into the Gulf of Mexico, never to be retrieved again. What if we took that water and reclaimed it and used it to water plants? In our local office, we can provide seasonal forecasts that can help them with the current or the upcoming growing season. So if we're expecting a dry spring into summer, they can start planning for how to use irrigation water, which they'll take from Falcon Lake.
Additionally, research is showing that integrating plants such as water lettuce, water hyacinth, and water spinach, cattails, and certain algae species can help improve water and soil quality. The effects of climate change on valley agriculture will be widespread and costly. The increase in temperature, changes in precipitation, and increasing salinity of water are some of the recent issues developing in local agriculture. Farmers in southern Texas can prepare for the changes by taking advantage of local services and using techniques mentioned in this video. Additional resources are available at climate.gov/BRO for local short-term and long-term weather predictions. For more information, please visit this website.